In today's video, I would like to discuss how we could solve the questions that we have on the test last time. So in order for us to have a better understanding of what is the question is all about, I first sketch out the memory diagram. At least we have a easy view on what we're supposed to do. So we start with a memory address, and the address is given by the metric numbers from your ID. So I would just assume, let's say your metric ID is 0, 2, and the last 8-digit numbers that you could find from your metric number would be 22, 01, 01, and 10. And these numbers will become the starting address of the memory location. For every single location in the memory is a byte value where you need to do a summation for every single byte start from here, and the total number of the byte that you need to do depends on the day of your birth. So let's say if my birthday is 26th of January, so the day of birth is 26. So this is the how many, so I need to do 26 times or 26 byte that I need to fetch from the memory and do a summation for all the value. In order for us to get a value from the memory location for every single byte, we have to use the opcode load to registers and with a prefix of B, so that we only get a byte instead of to get 4 byte or a word from the memory location. So I could start with a load R0 equals to 0x22, so that I could use register 0 as the address pointer for me to fetch each of the bytes from starting from that address. So once we have this R0 as address pointer, we can easily grab or fetch the value from our starting memory location, load a byte. So let's say we put it into register 1. So the data come from the memory and the address is given by register 0. And in addition, for every byte that I fetch from the memory and put in the register 1, I would like to increase the value of my address pointer or my register 0 instead of pointing to the first location. So next time it will automatically increase and go to the next address, which is 2201 and 0111. So in order to do that, I can have a post-index increment of 1. So basically what this would do is that once your processor has fetched or load the value from the memory pointed by register 0 to register 1, after you have completed the process, register 0 or my address pointer to the location will increase by 1. So they will jump to the next byte when the loop comes back again. So the reason why this has to be increased by 1 is that you are only need to fetch the bytes from the memory location instead of 4 bytes. So our address start with 0, so the next address supposed to be 1. That's why we have to increase by 1. Register 1 now has the first value from this memory location, but I need to do a summation to add every byte start from this value. Result of the summation need to be stored in somewhere. So I was assuming I would use register 2 for that purpose. So I can do add register 2 with register 1. My register 2 start with 0, so it will be 0 plus the value we get. So let's say this is the byte number 1, and we don't care much about what is the value there. So and the new value, like the existing register 2, add with the value we fetch from this memory location. After you add both and you store back to register 2. And then since we need to do it the same process, load and add for 26 times over and over again, so basically I will need a loop so that I will keep coming back to load the next byte and then add the next byte to my register 2. In order to do that, I would use another register. So for example, register 3. I will increase my register 3 by 1 every time I finish a loop, so that I can use register 3 to keep track how many times I have been adding the bytes to my R2. And then I can compare my register 3 with the value of 26, because that's the number of the times that I need to complete my process. I will branch as long as my register 3 is less than 26. So I will branch back to the line number 2, where I could fetch the bytes from the memory to the register 1. I'll just put a label there and to instruct my processor to come back to here. The register 3, let's assume it starts with 0. Now we're adding 1, so register 3 after the codes will become 1. Yeah, I think I better not using hash symbol. Let's change it to B1 as to indicate this is byte number 1. So of course we don't care what is B1, the actual value is, because it's a random value where you can find inside the memory location. So when we do the codes, the value that we find in that location will be just added to the register 2 up to 26 times as what we need to do in this question. So after the first loop, register 2 will have the value of byte number 1. Register 3 will have the value of 1 for the first, after you finish the first iteration. In this case, register 3 is still less than 26. That's why your processor will just go back to the label to redo the process in your loop. Just now, we have a post index for our load byte operation. Once your first byte has been moved to register 1, register 0 instead of 110 has increased to the value 111. If we're going to load another byte from the memory where the address is pointed by register 0, you are no longer fetching the byte number 1 because the address has been increased with the post index. Now we are getting the byte from the second location, or byte number 2, and put it into register 1. Register 1 now has a value of byte 2, and register 2 as we use to store our total result starting from this location and adding every byte start from there. On the second iteration, register 2, so byte number 1, which we get it from the first location, and now it has to plus with register 1, which we just got the value from the location number 2, B2, and the result is stored at register 2. After that, we're gonna increase our register 3 again as our loop pointer or loop index. Register 3 will equals to 1, because in the first iteration we have increased 3 to 1, so plus the 1 that we increase in this loop. After that, register 3 will become 2. So when we compare 2 or in register 3 to 26, of course this is still less than 26, your processor will come back again to redo the process. This is when our index is 0 or register 3 is 0. This is when the register 3 is 1, the index 1. So we need to do this process up to 26 times, depends on the day of birth. Every iteration that we come back in the loop, the register 0 just now was 111. After you have fetched, automatically it will increase by 1, so it will become 112. So if you would like to fetch again based on our codes, your processor will go and grab the byte number 3 and put it into R1. Again, repeat the process, adding R1 to R2 and increase our loop pointer or loop index compare whether it is include we have done it for 26 times. If not, just repeat the process again. Once your processor has successfully complete the loops, when it comes to the register 3 is equal to 26, it will no longer jump back to the loop because this is not less than 26 anymore. Then it will skip the branch and go to the next codes that you have in your program. And based on the questions, after you have done this 26 times and you get the total summation of 26 bytes, you need to compare whether the result, so our result is basically stored at register 2. So we want to see whether register 2, the value you have inside there, is it an odd or is it an even value? So how can we tell register 2 whether the value is odd or even, since we don't know what is the byte value we are fetching from the memory? And obviously you can't tell from the question itself because there are no absolute value which is given in the memory, and we assume all these things are random. If we look into the numbering system, so the odd number is basically 1, 3, 5, 7, and so on. And when you have an even number, 2, 4, 6, 8, and so on. If I convert the decimal numbers into binary, so this one will become 0, 0, 0, 1. And for the same process for even number, if you compare between the binary of odd and binary of even numbers, the first or the LSB of the numbers will tell you whether it is odd or even numbers. For the odd numbers, the LSB will be always 1, and for even numbers, the LSB will be always 0. So in order for us to identify whether register 2 has the value of odd or even, we just need to check the LSB or the first bit 0 in register 2, whether it's 1 or 0, then we can understand value that we found in register 2, whether it's odd or it's even. So of course, in order for us to do so, we need to filter out the rest of the numbers or the bits you find, because this is a 32 bits numbers. We have to filter out the rest of the 31 bits in front, but just keep the last bit that we want to know whether it's odd or numbers. And the way how we could do it is by using an AND operation and the register 2, because register 2 is the result that we want to check. So I would do an AND operation and the result is stored at register 2. And the process is to do an AND operation for every single bit from register 2 with 1. If you recall our previous lectures, when we do an AND operation with a certain value, whatever value is 0, it will put that to 0. And when you have a 1 bit, it will maintain whatever of the previous value. So after this AND operation, bit from bit 1 up to bit 31 will become 0. Only bit 0 will be either 1 or 0, depends on the original value. If the LSB or bit 0 is 1 and you end with 1, in this case, and you will get 1 as a result. However, if the bit 0 and you do an AND operation with 1, the result will become 0. And with these two values that I will end up to register 2, I can tell if the last result you get from register 2 is 1, then this is an odd number. And instead of that value is 0, then I can say that whatever value in register 2 after your summation of 26 times is even numbers. You can do the comparison between register 2 and with the value of 1. If this is equal, means register 2 is equal to 1, then this is a odd number. If odd number, it will go to somewhere, let's say we go somewhere down there. So in here that where we could store our result to 9,000, or somewhere between here is where the numbers is even, because the register 2 is not equals to 1, because register 2 is equal to 0 when this is even numbers. So when this is not equal, it will not branch to odd. It will skip the branch operation or your opcode. Continue whatever code you have after this. So basically, you just need to complete the operation to store a number or the result into the address of 9000. Because this is even numbers, you need to complete the codes to store the result into address 8000, since this is the odd numbers. So with that, this is the answer for the question number 2 in your test.